So on Wednesday, we covered the graphs of the sine function, y equals sine x, and the graph of the cosine function, y equals cosine x. And then on page 2 of your handout, right, we noticed that the graph of the sine function and the cosine function only differ by a phase shift of pi/2 radians. Okay, and remember, phase shift is just another word for horizontal shift. Okay, and then at the end of class, right, we're starting to discuss graphing transformations of the sine and cosine function, right, of the form y equals a times the sine bx plus c, and y equals a times the cosine of bx plus c, right, where a, b, and c are real numbers. And we noted that the absolute value of a, okay, which is what sine and cosine are being multiplied by, right, that is called the amplitude, and that just tells you the amount of the vertical structure compression in the graph, in the transform graph of the sine and cosine function. The period is found by taking 2 pi and dividing it by the real number b, and b has to be greater than 0, it has to be positive. And so the period, right, from page 1 is just the length of one cycle in the graph of the transform sine function or cosine function. And then the absolute value c over b, right, that's the phase shift in the graph of the transform sine or cosine function, right, and that's how much the graph gets shifted to the left or to the right. Okay. So in the exercises below, we're going to determine the amplitude, period, and phase shift, right, of the transformed sine or cosine function, okay, without actually graphing it. So in the first example, right, we have a transformation of the sine function. Right? Y equals the sine of 3x minus pi over 4. And so in this example, right, then a is the invisible 1 out front, b is equal to 3, and c is equal to minus pi over 4. So the amplitude which is just the absolute value of a, right, and a is equal to 1, and the absolute value of 1 is 1. Right? So the amplitude is equal to 1 in this case, so there's no vertical stretch or compression in the graph of this transform sine function. The period the length of one cycle in the graph of this transform sine function is equal to 2 pi over b, where b is equal to 3. And so the period, right, in the graph of this transform sine function is 2 pi over 3 radians. Okay, that's the length of one cycle. The phase shift, which is the amount of the horizontal shift, is equal to the absolute value of c divided by b. Okay. And the absolute value of c is the absolute value of minus pi over 4, which is plus pi over 4. And then b is equal to 3. And pi over 4 divided by 3 is equal to pi over 12. So the amount of the horizontal shift, the phase shift, is pi over 12 radians. Okay. Now, because c is negative, the shift is going to be to the right. So when you have minus something up here, right, it shifts to the right. So without graphing, right, we know there's no vertical stretch or compression. The length of one cycle is 2 pi over 3 radians, and the amount of the horizontal shift is pi over 12 radians to the right. Okay. In the next example, we have y is equal to minus 2 times the cosine of 2x minus pi over 6. So a is equal to negative 2 in this case. B is equal to plus 2. And C is equal to minus pi over 6 radians. So the amplitude is equal to the absolute value of A is equal to plus 2. So the graph of this transform cosine function has a vertical stretch by a factor of 2. The period, the length of one cycle, is equal to 2 pi divided by B. B is equal to 2. And so the length of one cycle or one period, okay, the graph of this transform cosine function is pi radians. The phase shift is equal to the absolute value of C over B. C is minus pi over 6, so the absolute value minus pi over 6 is plus pi over 6. B is equal to 2, and pi over 6 divided by 2 is pi over 12. So again, right, for this transfer cosine function, right, the horizontal shift is pi over 12 units, okay? And because B or C is negative, right, the shift is to the right by pi over 12 units. Any questions on that, ladies and gentlemen? And then lastly, we have y is equal to 5 times the sine of 4x plus pi over 4. So in this example, right, a is equal to 5, b is equal to 4, c is equal to pi over 4. The amplitude is equal to the absolute value of A, which is, right, A is equal to 5, absolute value of 5 is 5. And so the graph of this transform sine function, okay, has a vertical stretch by a factor of 5. The period, T, is equal to the length of one cycle, is equal to 2 pi over 4, which is the same as pi over 2. So the length of one cycle is pi over 2 radians. And then lastly, we have the phase shift, which is the amount of the horizontal shift. Absolute value of C in this case is the absolute value of pi over 4, which is pi over 4. And B is equal to 4. And pi over 4 divided by pi, or pi over 4 divided by 4 is pi over 16. So the graph of the sine function, right, gets shifted to the left pi over 16 units. Which direction? Left or right? It's to the left because this is positive, plus pi. All right. Any questions on that? So if you flip over your page, let's graph a transform sine function. Now there's graphing on the final exam, so it's important that you understand this, what goes on in this page. Okay? In your bonus quiz, right, you get to graph one of these things. Okay? So we're going to graph the transform sine function. F of x is equal to 3 times the sine of 2x minus pi over 4. Okay? And so you can see for this example, A is equal to 3, B is equal to 2, and C is equal to minus pi over 4. You gotta fill in some blanks. We can fill in two of them really easily right now. Amplitude is the absolute value of A, which is 3. So the graph of this sine function, your transform sine function, right, is a vertical stretch of plus 3. Okay. The period, T, is equal to 2 pi over B. B is 2. And so the period is pi radians. Okay. One cycle is pi radians long, pi units long. Okay. We'll have to figure out what the x-intercepts are in the graph. And we're going to have to find the x and y coordinates, okay, for the first positive local maximum and minimum. Okay. So what we got to remember, okay, for one cycle of the basic sine function, right, starts here, goes up, comes down, goes up, right? This is one cycle. But this one cycle is being transformed, right? It's being vertically stretched, okay, and it's being compressed because the period is no longer 2 pi radians, it's pi radians, okay? And then it's being shifted, right, to the right or to the left. So we got what we end up graphing, right? We'll have this shape, right? But it'll be stretched, vertically compressed horizontally, and then shifted to the left or to the right. All right. So remember what goes in to the sine function, right? In mathematics, we call that the argument. And so the first thing we're going to do is find the beginning and the end of the graph, right? Where it starts and where it ends in the coordinate plane. And so what we do is we take the argument and we set it greater than 0 and less than 2 pi. Now the reason we do that is that for y equals sine x, okay, the period is 2 pi radians. Right? So the graph here, right, starts at 0, ends at 2 pi. So since this is a transformation of that graph, we take the argument and set it greater than 0 and less than 2 pi. And now we solve for x. Now we learned and reviewed how to solve right? This is called a compound inequality. Right, we solved these on exam 1, right, back in chapter 1, beginning of the semester. And so to solve for x, right, first thing we do is add pi over 4 to all three sides. So 0 plus pi over 4 is less than 2x minus pi over 4 plus pi over 4 is less than 2 pi plus pi over 4. So on the left, we just have pi over 4. Minus pi over 4 plus pi over 4 is 0. So we just have 2x in the middle. And on the right, 2 pi over 4 is the same as 8 pi over 4. And 8 pi over 4 plus pi is 9 pi. And now on solving for x, you can divide all 3 sides by 2, or multiply all 3 sides by 1/2, right? Dividing by 2 and multiplying by 1/2 are the same thing. So since we've been doing division over here, maybe we'll just divide all 3 sides by 2. And pi over 4 divided by 2 is pi over 8. 2's cancel in the middle. And 9 pi over 4 divided by 2 is 9 pi over 8. So in the graph of our transform sine function, right, for one cycle, we begin at pi over 8, pi over 8, and end at 9 pi over 8. Now if you subtract 9 pi over 8 minus pi over 8, that difference is equal to pi. And we said up here, right, the period is equal to pi. So that's consistent with our calculation for pi. Okay. So now you got to label the x and y axis. Okay. So here's the origin. Right? So here's y equals 1, y equals 2, y equals 3, y equals 4, y equals minus 1, minus 2, minus 3, minus 4. And then you got to decide, okay, each square is how many units, okay. And when I set it up, I decided each square was pi over 8 units. So that you have 1 pi over 8, 2 pi over 8, 3 pi over 8, right? We'll come and fill that in. 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8, 9 pi over 8. And so from page 1, we know our graph is going to begin here on the x-axis and end here on the x-axis. Now you look at page 1 for one cycle. Starts here, then here, goes up here, then here, then here, then here, right? In my table of x and y values, right, I had 5 x values, right, that correspond to these 5 points. So we're going to need 5 x values, right, similarly on this page. Okay. So we know the first x value, we know the last x value. Okay. We need to know the other 3. So the first thing we can do is calculate the middle x value, right? So here's 1, 2, 3, 4 hash marks to the right of pi over 8. And here is 1, 2, 3, 4 hash marks to the left of 9 pi over 8. Well, the value on the x-axis at that hash mark is the average of these 2 numbers, right? So to find the average of pi over 8, maybe we'll do it down below. To find the average of pi over 8 and 9 pi over 8, right, you add them together. And then you either divide by 2 or multiply by 1/2, right? That's how you find the average of 2 numbers. Well, pi over 8 plus 9 pi over 8 is 10 pi over 8. And however you like to do your arithmetic, right, this turns out to be equal to 5 pi over 8. So 5 pi over 8 is the middle hash mark. So given the shape of the graph on page 1, you know this is going to be an x-intercept, this is going to be an x-intercept, and this is going to be an x-intercept. At this hash mark right here is where the top of the graph is, and at this hash mark right here is where the bottom of the graph. So now we find the middle point between pi over 8 and 5 pi over 8 at this hash mark, right? This is where the maximum, right, the high point in the graph will be. So we have 1/2 of pi over 8 plus 5 pi over 8, which is equal to 1/2 times 6 pi over 8, which is equal to, however you like to do your math, is equal to 3 pi over 8. So this hash mark right here is equal to 3 pi over 8. So at 3 pi over 8, right, so the graph goes up, and then it's going to come back down. So at 3 pi over 8, right, remember the amplitude is 3. So the height of the graph at x equals 3 pi over 8 is 3 units above the x-axis, right? So it's going to go up. Y equals 3. And then it's going to come down. Try to draw it as smooth, best as you can, as a smooth curve. And then it's going to come down and cross the x-axis at 5 pi over 8. And now we got to find the value, right? The value of x at this hash mark, halfway between 5 pi over 8 and 9 pi over 8. So the average of those two numbers, 5 pi over 8 and 9 pi over 8, is equal to 1/2 times 14 pi over 8, which is equal to 7 pi over 8. So at 7 pi over 8 is where the lowest point in the graph occurs. And because the amplitude is plus 3, right, the y value at 7 pi over 8 is minus 3. And so the graph comes down to y equals minus 3, and then goes back up to the x-axis at 9 pi over 8. Okay. And we have graphed this transformed sine function for one cycle, one period. So now, right, you know where the x-intercepts are. They're pi over 8, 5 pi over 8, and 9 pi over 8. Remember, x-intercepts is where the graph touches or crosses the x-axis. Where does the maximum occur? At this point right here, right? Which has an x-coordinate of 3 pi over 8. Oops, yeah, x-coordinate 3 pi over 8, and a y-coordinate of plus 3. Where does the minimum occur? At this point right here, has a x-coordinate of 7 pi over 8 and a y-coordinate minus 3. And we've answered all the questions. Any questions on that, ladies and gentlemen? Yes, sir.
Why is not an average instead of kind of like 1 pi over 8, 2 pi over 8, 2 pi over 8, 4 pi over 8?
I could have done that. It was, the numbers were so nice, but a lot of times the numbers aren't that nice. okay? You might be starting at pi over 6 and have to add pi over 4, right? And so now you got pi over 6 plus pi over 4, right? So the denominator keeps changing. And so I thought about that. I should maybe change the problem so that it wasn't. But in this case, you could do that very thing, right? Pi over 8, 2 pi, 3 pi over 8, 4 pi over 8, 5 pi. But you can't always do that. The numbers aren't always that nice.
That makes sense.
Okay. All right. Any questions? All right. So in this handout, right, we begin by talking about double angle formulas. And in trigonometry, there are a lot of formulas. And you can't remember them all. So in the double angle formulas, right, we have, the first one we have is the sine of 2x is equal to 2 times the sine of x cosine of x. So what you should note is that x is an angle and 2x is an angle twice the size of x. Okay, that's how you should interpret these things. X is an angle, okay, and 2x is an angle twice the size of x. Okay. So in the exercise, we're given the cosine of the angle x is equal to 1/4, where the angle x is greater than 3 pi over 2 radians and less than 2 pi radians. So we're given the cosine of the angle x is equal to 1/4, and the angle x is greater than 3 pi over 2 radians and less than 2 pi radians. And you reckon that 3 pi over 2 radians is the same as 270 degrees. 2 pi radians is the same as 360 degrees. And so angle x, right, is in quadrant 4. And the cosine of any angle in quadrant 4 is positive, so cosine x equal to 1/4 makes sense. So given this information, we're asked to find the cosine of the angle 2x. Okay. Well, there are 3 ways that you can calculate the cosine of 2x. There aren't 3 answers, there's only 1 answer. But there's 3 ways to calculate the cosine of the angle 2x. Right? You can calculate it by squaring cosine x minus the square of sine x. Or you can calculate it by multiplying cosine squared x by 2 and then subtracting 1. Or you can subtract 2 times sine x squared from plus 1. Those are 3 different ways that you can calculate. Well, you're given the value of cosine x, so the second version of the cosine of 2x is equal to 2 times the cosine of x squared minus 1. We know cosine x, so we can use that version to calculate cosine of 2x. Well, cosine x is equal to 1/4. So cosine 2x is equal to 2 times 1/4 squared minus 1. And now it's arithmetic, right? You gotta do PEMDAS. 1/4 squared, right, is 1/16. Then you have 2 times 1/16 minus 1. 2 times 1/16 is 1/8. And 1 can be written as 8/8, right? So you have 1/8 minus 8/8. And so the cosine of 2x is equal to minus 7/8. That's the easy part. Okay. Next, we got to calculate the sine of 2x. Okay. Well, to do that, we got to figure out what the sine of x is. Okay. Well, because x is in the 4th quadrant, we know that the sine of any angle in the 4th quadrant is negative, right? Less than 0. It's important information. Okay. So from section 4.2, right, we learned the Pythagorean identity, cosine x squared plus sine x squared is equal to 1. Well, cosine x squared, or cosine x is 1/4. So cosine x squared, right, is 1/4 squared. So we have 1/4 squared plus sine x squared is equal to 1. And so now we solve for sine x. Well, 1/4 squared is 1/16. And now we subtract 1/16 from both sides, right? And we have sine squared x is equal to 1 minus 1/16, right? 16/16 minus 1/16, which is equal to 15/16. So sine squared x is equal to 15/16. And now, to solve for sine x, we take the square root of both sides. But we said that sine x has to be negative, so we take the negative square root on the right-hand side. The sine x has to be negative. And so we have sine x is equal to the negative of the square root of 15/16, which reduces to the square root of 15 over square root of 16, which is 4. So that's what sine x is equal to. And now we can calculate the sine of 2x, right? This is what we're after, right? The sine of 2x, using this form, right? The sine of 2x is 2 times the sine of x times the cosine of x. So the sine 2x is equal to 2 times the sine of x times the cosine of x. Sine x is root 15 over 4. Cosine x is 1/4. So the sine of the angle 2x is 2 times the square root of 15. And 4 times 4 is 16. Well, 2 over 16 reduces to 1 over 8. So we have the sine of 2x is equal to, I made a mistake. Did you notice it? I forgot the minus sign. Sine x. Sine x minus the square root of 15 over 4. And so this is minus 2 times the square root of 15 over 16. And 2 over 16 still reduces to 1 over 8. So we have minus square root of 15 over 8. Any questions on that, ladies and gentlemen?